We're going to finish up lesson 3.9 by looking at uniform motion problems. Motion problems are another application of weighted averages. Uniform motion problems are problems where an object moves a certain speed or rate. The formula distance equals rate times time is used to solve these problems. In the formula, D represents distance, R represents rate, and T represents time. You'll want this in your notes. Marisol took a nonstop flight from Newark to Austin to visit her grandmother. The 750-mile trip took 3 hours and 45 minutes. Because of bad weather, the return trip took 4 hours and 45 minutes. What was her average speed for the round trip? To find average speed for each leg of the trip, rewrite distance equals rate times time by dividing both sides by time as rate equals distance divided by time. Now, unfortunately, there are not 100 minutes in an hour, so in order to write 45 minutes as a decimal, I need to divide by 60, so I get 0.75. So I've got 3.75 plus 4.75 for my times. So my total distance was 1,500, which is what they had typed in the problem. And if we divide the total distance, the distance there and the distance back was 1,500 divided by the total time was 8.5 hours, we get 176.5 miles per hour. A railroad switching operator has discovered that two trains are heading toward each other on the same track. Currently, the trains are 53 miles apart. One train is traveling at 75 miles per hour, and the other train is traveling at 40 miles per hour. The faster train will require 5 miles to stop safely. The slower train will require 3 miles to stop safely. About how many minutes does the operator have to warn the train engines to stop their trains? This is an unfortunate twist on a classic train problem because they're on the same track, so that's a bummer. The first train, they said, would take 5 miles to stop, and the second one takes 3 miles to stop, and they're 53 miles apart. We have a nice diagram to fill in here. Distance equals rate times time. The rate of the faster train was 75 miles per hour, and the slower train was 40. And they let M equal the number of minutes the operator has to warn the train engineers to stop the train safely. Distance equals rate times time. Now the problem said that it was going to require 5 miles to stop the faster train and 3 miles for the slower train, so we really only have 45 miles to deal with because we want them stopped. That would be good. So the distance traveled by the faster train was 75 m, and the distance traveled by the slower train was 40 m, and together we only have 45 miles to get these two guys stopped. If we combine our like terms, 75 m plus 40 m is 115 m, so divide both sides by 115 and we have 39 hundredths of an hour. It'd make more sense if we were talking about minutes. So if we change hours to minutes, there are 60 minutes in an hour. So 39 hundredths times 60, I get about 23, it's 0.47. We're going to call it about 23 minutes to get them stopped. We use the formula distance equals rate times time to solve uniform motion problems.